Hello and welcome to the Working from Home webinar series by Aculon. Today we're going to be talking about anti-fingerprint solutions. This is our fourth in our series of Working from Home webinars. Thank you for joining us. My name is Edward Hughes. I'm the CEO of Aculon. I'm going to be joined by Dr. Eric Bruner, who's the president and founder of Aculon and a specialist in our technology, and he's going to be leading the discussion regarding the anti-fingerprinting solutions. Also joining us today is Mary Gattuso, a Senior Business Development Manager. Firstly, thank you again for taking the time to listen to this webinar. I hope everybody is well and safe. Clearly, we are living in very unprecedented times. This pandemic has taken us all by surprise in terms of the scope, the speed, and the stakes of what has happened over the last month. February seems like an eternity ago. Obviously, everybody's having to adapt to this working from home scenario, and so we wanted to basically take some time while hopefully you have the time to talk about some of the latest innovations in surface modification technologies in this series of webinars. Aculon as a company is deemed as an essential company. We supply to many medical device companies, and so we continue to operate and produce and to test and to continue to work with customers. But today we really wanted to educate you on some of the technologies we've developed so that you know that we're there for you when you come out of this. Our goal as a company is we want to enable customers to make better products by being an innovative, responsive, and fast developer and producer of best-in-class surface modification technologies. We believe that together we create winning products. The agenda for today is very simple. I'm going to give you a quick overview of Aculon for some of you who are not so familiar with us. And then Dr. Bruner is going to take you through some approaches, talk about anti-fingerprinting in terms of coatings, textures, colors, and how to characterize that. And then I'm going to add some bonus material for you because I know many of you work in many different areas in your organizations, and some things that could be interesting to you we will share at the end. Aculon as a company works in many different fields, whether it's electronics, whether it's medical devices, whether it's oil and gas. We've looked at thousands and thousands of applications. We were founded in 2004, and our expertise is all about surface modification. We develop and produce surface solutions to modify a broad variety of surfaces, whether it's metals, glass, polymers. We can add a variety of functionality: hydrophobic, superhydrophobic, oleophobic, hydrophilic, anti-fingerprinting that we're going to be talking about today, and even adhesion promotion. Our treatments are all thin. They're easy to apply. We have a low capital intensity kind of model, so no vacuum chambers. Often there's no cure. They are safe, they're non-toxic, and we also offer green options as well. We like to think we differentiate ourselves by not only coming up with proprietary innovative treatments, but really a willingness to work with customers to solve problems. Working together and solving the customer's problems is what we do. We have three main areas: electronics, oil and gas, and specialty, which includes our medical devices. And our business model is predominantly to produce chemistry. We work with customers to qualify their parts, so we may treat some parts in-house, and then ultimately they will be shipping the chemistry to the customer or to their subcontractor to apply to the actual component. We have over 35 patents granted. We've worked with thousands of applications, and we've invested hundreds of thousands of hours building this expertise in surface modification. We've got over 100 products, and our people are smart. We have numerous chemists with PhDs, master's degrees, a lot of electrical engineers and mechanical engineers as well. We're headquartered in San Diego, California. That's where we have our main lab and our manufacturing facility. We have offices in Shanghai, Singapore, Dallas, Amsterdam, and then we have a number of distributors that cover the Asian market in particular. When the company was started, we really started with a technology called self-assembled monolayers phosphonates, and that was the initial work on surface modification. Since then, we've added a suite of technologies that are designed to basically solve customers' problems. So over the years, as customers have come to us looking for issues they're trying to fix or functionalize their surface, we've added these technologies. The initial technology was very flexible in that you basically anchors to an oxide group on the surface, and then you have an R group that allows you to basically pick different types of functionalities. And so we were able to customize this and develop a lot of different options. And that was a great starting point to build out this portfolio, where today we have a large number of product groups, whether it's repellency or attraction treatments, anti-fingerprinting, waterproofing, or even surface cleaners. And we have, within those product groups, we have different functionalities, as you can see from this page here. So we've got this broad suite of products with a broad suite of functionalities that we try to use to dial in and solve customers' problems. Our technology all is easy to apply, so it can be as simple as dip applied, it can be spray applied, wipe or roll to roll, and we will customize and vary a number of parameters to basically either speed up the process or to achieve the level of performance that the customer is looking to do. So we've built a suite of platforms around this kind of expertise on surface modification. Initially we worked quite a lot in the display and the optical space. We've added adhesion promotion. We do a lot in water barrier protection. We did a whole webinar on that a week or two ago. We do a lot in metal treatment, whether it's electronics and industrials. We do work in the enhanced oil recovery space and anti-fouling, anti-fingerprinting, which is what we're going to talk about today, and hydrophilics. So with that, let me turn it over to Eric Bruner to talk a little about the anti-fingerprinting.
Thank you, Edward, and thank you, everybody, for joining us today. This is a problem that I think most of you are aware of. Fingerprints are, composed of materials from our sweat glands. Fingers leave behind impressions of, ridges, usually from the finger, and they're composed of water, fats, fatty acids, esters, squalene, and salts. So next slide. And there's a lot of different devices that we touch, whether they're laptops or mobile phones, consumer appliances, optics. A lot of things that are handled where you don't necessarily want the fingerprints visible. You want to see this beautiful phone. You don't want it having lots of kind of oily, smudgy fingerprints on it. And so the way to deal with that is, there are a number of different approaches, and we're going to discuss those today. It's a multifaceted issue. So it's not just about a coating, it's also about the substrate. And so we're going to explore that. Kind of the way we typically approach this is through surface treatments. And there's two generally main ways of addressing fingerprints, either through hiding power, which focuses on the surface energy and how the fingerprint interacts with the surface. And the other approach is just providing an easy to clean surface. So, decreasing the interaction of the oil with the surface so that it's allowed to be removed. And generally that's done with, oilophobic properties, which are, oil repelling. So for AFP, there's a couple different things. If you're working with a substrate where it's opaque and you've got reflection from the surface, one of the main things that you want to try to do is reduce the appearance of the fingerprint. So you want the light to have minimal disruption as it goes through the fingerprint and reflects from the surface. You can also, of course, offer easy clean properties, which make it easier to clean. And the other, important thing for all of these applications is that the coatings are durable. It's one thing to solve the problem, but you also want to solve it for a long period of time for the life of the device. So for anti-fingerprint coatings, you want to change how the light interacts, and then you also want to significantly improve the ease of cleaning. You can see from the diagram, an untreated surface, you see the oils kind of just wet out. They may stick there, be hard to remove. Whereas an easy clean approach, you usually are seeing the oils start to beat up. There's a layer of phobicity on the substrate, and then it allows them to be easily cleaned either just by wiping with a dry cloth, or your T-shirt, or whatever is convenient is usually what the consumer uses. So our coatings chemically bond to the surface, and that's important because that allows them to be very durable. When you have a covalent bond, you essentially are attached to that surface, and we're generally as durable as the underlying surface. So you can see here with some of our easy to clean coatings, you can see that even after 2,000 hard force 600 grams per square centimeter force, that you're seeing the repellency both to water and oil remain intact. There's a slight decrease, but that's a pretty good result. So the other way to attack this problem is to work with the substrate. Substrates generally have either color or texture, and for texture, you have kind of on one extreme you have really glossy, flat surfaces, and on the other extreme you have a matte finish, which is rough. And generally roughness helps because it helps hide the fingerprint, and we can show that in a subsequent slide, but it's definitely a tool that can be used. So the thing about matte finishes is they cause the reflection of light to go in many different directions, and so that helps hide the fingerprint. It kind of essentially diffuses the reflection out so you don't see it as well. It doesn't reflect as much light, so the appearance of the surface is a little bit dulled, but it definitely helps hide the fingerprint. Glossy, on the other hand, is very flat. It reflects a lot of light, and there's some desire of, depending on the industrial designer of the device, what they want. They may want a glossy surface. Matte may not be an option, and in this case, you have to, there's some tricks to play, but it's it kind of, unfortunately, glossy surfaces maximize the appearance of fingerprints. So, and then the other thing about texture is the viewing angle can have there's a dependence. So depending on which way you're looking at a surface, you may or may not see the fingerprint as much. Generally, at the widest degree of angles, matte's the best, because whether it's medium or low viewing angles, you get that diffuse reflectance and it minimize it. Now, high viewing angles, straight up and down, may not be as good, but generally matte's good, and also changing how the oil sits on the surface can be important at different angles as well. So yeah, this is once again, increasing the matte level helps hide the fingerprints. You can adjust the surface texture in parallel with AFA coatings, and that helps kind of maximize your performance. And so we usually go through the exercise of when we get either a new project or working with a new device, we'll look at kind of different ways to adjust the AFP with the specific surface texture that's been chosen to kind of maximize the results. So the last kind of general way to affect anti-fingerprint coatings is to adjust your color. That may be predefined by a particular device, but there's certainly some colors that are better than others in terms of improving AFP performance. So colors that have high absorbance, darker substrates, Okay, I think I've got it here now. I think there was a little bit of a delay. Sorry about that. Yeah, the effects of color are, you know, like I said, the darker colors tend to show a higher level of fingerprinting. You know, lighter colors do a better job of hiding them due to the high reflectivity, and you don't have as much of a contrast. So, you know, different colors require different solutions, and so we actually have different coatings for different colors. You know, we'll tend to make things, you know, much easier to clean on the lighter colors, and on the darker, we concentrate more on the FP side of things to kind of help blend the fingerprint in and minimize its appearance. So this is an important slide, actually. Surface characterization is important because it allows us to look at the changes and judge performance. So one of the primary ways to do that is to look at gloss, essentially in percent reflectance at different angles. There's some relatively inexpensive either BYK or Elcometer models out there, which do a nice job of just kind of giving you some baseline readings on, you know, trying to quantitate how much smudging is going on. For colored and textured surfaces, we have another instrument that's made by BYK that's called an IMAC, and this one is, you know, essentially, you know, a spectrophotometer that looks at reflections and it gets a full spectrum, and so you can, and it looks at different angles, so you're able to really characterize the amount of absorption that's going on at different angles and look at the different colors. So and also it looks at some other attributes like the sparkle and the graininess, so it allows you to kind of get a better picture. So in summary, Aculon has a series of products that help provide anti-fingerprint performance, and you know, kind of the key advantage that we have is the tunability of the coating, the fact that we are chemically bonded to the surface and very durable, and you know, we have the tools to be able to kind of characterize and customize the coating for the customer and help reduce both the appearance of the fingerprint as well as making it easy to clean. And we have some of the best, in terms of oil repellency, we have some of the best oil repellency that I know of on the market. We've got oil contact angles, you know, reproducibly over 75 degrees, upwards of 90 degrees for squalene. And, you know, that's great because it makes those surfaces really easy to clean and are durable to abrasion. So thank you, Edward, and thank you all again for joining us today.
Great, thanks, Eric. And please submit questions in the question box, and we'll try and tackle as many of those questions as possible at the end of this webinar. So, and I should have mentioned that the webinar is being recorded, and you will get a link, an email, which gives you a link to not only the presentation but also to the webinar. So that obviously, as Eric went through some of the details of anti-fingerprint treatments, you'll be able to obviously, you know, have that information for future reference. So let me talk about a couple of bonus material things, a couple other things that may be of interest to you. We do a lot in the waterproofing space. We have a series of products under the NANOPROOF line of products that are designed to protect devices from as low as humidity protection all the way up to full water immersion. We've got a variety of proprietary technologies. The application, again, methodology is straightforward, it's affordable, and the equipment's readily available. And we can get a range of thicknesses and performances based on what you need. Not everybody needs to have full immersion. Some people are looking for splash protection. So we have a range of products that allow you to do this. And we've been doing this now for about 6 years. And we've developed a series of products that over time we've been increasing the performance in terms of the barrier properties that are necessary for certainly a kind of full water immersion in the IPX8 level type of performance. We've also added a series of features, some of which can include push-through connectivity, so allow you to connect the device or the display screen post the application of the treatment. We have more recently, because obviously electronics are looking for more flexibility required and flexible circuits, added a flexibility as a requirement into some of the newer treatments. So you can get a 180-degree bend on that. And we've also got some green options, some VOC exempt options, as obviously people around the world are getting increasingly concerned about VOCs. So we have options that allow you to do a variety of things to achieve this waterproofing. Obviously, the benefit of this is that we are helping you protect your devices, so there's less returns because of water damage. These processes are different than vacuum deposition processes or conformal coating processes that cannot be reworked. These can easily be reworked. And the beauty is that they require no or minimal masking, particularly if you've got push-through connectivity. The coatings are safe, they're non-toxic. You don't need you need ventilation, but you don't need scrubbers and those type of things to do that, and they can be used obviously in all factory environments, and they're affordable. The equipment is readily available. It can include spray, jet, dispense, dip. It could be from good partners like Nordson or PVA, or other people who have equipment as well. So as you can see, it's some places it's going to be set up for high volume manufacturing and want to have spray type applications. Other cases, lower volume, lower capital intensity, and we have options for as simple as dip treatment as well. So there's lots of details in our white papers on this, but we can basically deliver waterproof capabilities, 18 volts, powered circuitry with no current leakage. So it's a pretty cool set of products that we have there. One other area we think is kind of maybe interesting to use, this is in the SMT area for stencils. This is a product we've had on the market for about 6-7 years, where basically the NANOCLEAR product, we apply a extremely thin film, flux repellent to the underside of the stencil, and it coats the aperture walls. Obviously, the goal here is to basically improve your printing process, reduce the number of misses, voids, blocked apertures, and in doing so, you'll get increased quality, increased yields, better transfer effectiveness. You'll also boost your productivity because there's less stencil underwiping that takes place. You can increase dramatically the number of prints to one underwipe. And obviously there's less downtime for paper changes as well. And as a result, you save money, there's less rework, the quality of the printing's better, and you save on the consumables as well. And we think this is kind of we like to say NANOCLEAR is cheap, simple, and works every time. Oops, I skipped ahead too fast. And here's an ad that we're just going to start going out with, so we're having a little bit of fun here. But I told my doctor I had PD. He prescribed NANOCLEAR. So obviously we think this is going to be we have many customers that when they have a printing issue, basically they apply NANOCLEAR to the stencil and it works every time. So we hope that if you are in the SMT world as well, then please take a look at this. This has been a product that's got a lot of serious media coverage behind it, a lot of technical papers, a lot of articles on and case studies showing that dramatic improvements in that. And as they say, it's simple, it's cheap, and it works every time. So it is the #1 nano coating for stencils globally, and there's lots of good data around that. So from an IP standpoint, the company has a strong patent portfolio, and I kind of call it hard IP and soft IP. So we've got lots of patents, lots of trade secrets. We've treated and tested thousands of applications. We have access through UCSD here in San Diego to millions of dollars of equipment. We spent hundreds of thousands of hours solving surface problems, and we've invested millions of dollars building capabilities to do that. We also want to be good citizens of the planet and to offer you, our customers, environmentally friendly solutions, so that Obviously, many of you have your own sustainability goals, and we want to help you achieve those. So we have options that are VOC exempt. We don't have any PFA products. We use eco packaging and waste reduction, and obviously try to be as efficient as possible on transportation and use of energy in our operations. So in conclusion, we are a platform technology company that makes customers' products better. That's what we do. We like to work with customers to solve the problems. We think we are surface solution experts, and we have worked with a lot of customers over the years to basically solve problems and implement them in whether it's small scale operations or high volume manufacturing. We have a broad portfolio of products, including a number of sustainable options. And we kind of combine that with a strong IP, great in-house testing capabilities, and in-house expertise to hopefully make your products better. So with that, let me stop and let me see if we have any questions. So I'll open the question box, and if you can type in any questions you have, we'll try and tackle as many as possible as we go through. All right, so let me... Okay, this first one's for you, Eric Bruner. Along with anti-smudge performance, can any antimicrobial performance be incorporated on glass substrate at once?
That's a good question, especially the current state of affairs. I think there's a lot of interest in doing so. It's not something historically that we've done, but it is something we are looking at. We recognize the need for disinfecting surfaces, and there are some strategies to incorporating antiviral agents into coatings, and we are looking at those. They're not off the shelf ready to go, but it is something that we're actively pursuing.
Okay, next one's also for you, Eric. Do some substrates work better than others supporting anti-fingerprinting functionalities? For example, anodized aluminum versus glass versus other polymers.
Yeah, absolutely. There's certainly an important function that the substrate plays. Essentially, the more light you get reflected or through the product, the easier it is to kind of hide fingerprints. The more opaque and dark the substrate is, the more the contrast occurs when you have a fingerprint event. So yeah, that kind of gets into some of the basic tenets of the presentation, where you can affect performance by changing the substrate. And fortunately, we have a broad range of treatments that can go down on a broad range of substrates and kind of tune that. So, if you want to reach out to us with the substrates that you're interested in, we can give you some answers on some recommendations.
Okay. Another one I can easily handle. May I have a copy of the presentation? Yes, we will be sending a link to all the participants, and you'll be able to get a copy of the presentation. Another one, Eric, for you. We've looked at anti-fingerprinting, but struggled with measuring it to get consistency, as different people have different fingerprints and amount of oils. So I know this is something that you deal with quite a bit.
Yeah, that is a great question, and a challenging one. It is relative to the person, and it is relative to the person, maybe even what they ate that day. So there's a the composition of the oils of your fingers change, and trying to quantitatively judge performance is challenging. What we've done generally is we'll have, when we're looking at something, we will, if we're doing actual fingerprinting and viewing of those fingerprints, we will try to judge all of the series at the same time by the same person with the same amount of force. And so, whether you're doing a light fingerprint or a heavy fingerprint affects what you see. And so, there are some synthetic-based, sweat, or just using squalene oil by itself sometimes can help reduce the variability. But it is a challenging one, and it's one that we face as a challenge. But like I said, I think just trying to get a controlled environment where you have the same person, same day with the same amount of force, you get some relative comparison, but it is a relative comparison on a day-to-day basis.
Okay, another one for you, Eric, and this may have come in earlier in the webinar. How are you defining durability?
Durability has really two main things. One is the abrasion resistance. So we use linear abrasion. So we have a machine that will rub a surface back and forth with a certain amount of force. Typically, we'll use a material that's relative to the application, whether it's blue jean material or a cotton t-shirt type material, either wet or dry. So mechanical abrasion is one of the primary ways we look at durability. The other way is chemical durability, and that's kind of gets to what kind of cleaning agents may be used for the device. Maybe you want to test against stability towards Windex or isopropanol or other types of cleaning agents. So it's mainly mechanical and chemical durability that we look at.
Okay, great. Another one for you. Is there any quantitative assessment of anti-fingerprint performance, quantitative methods, or standard protocol?
Yeah, this is similar to the previous question. Just trying to, it's a challenging one. The equipment we presented in the presentation are a pretty good start. Gloss meters, the BYK is really useful. There's more advanced techniques out there. Laser confocal microscopy can help image, especially if you're able to register the part before and after fingerprinting. But the main way to look at this is with light. If it's a transparent substrate like glass, you can use like the haze meters or haze guards. Look at transparency, clarity, and percent haze before and after fingerprinting. If it's a opaque substrate, you're mainly looking at reflection of light, and so you want to look at changes in that reflection. With fingerprinting against different coatings that you use, and see which one kind of minimizes the appearance of that fingerprint. And then last but not least is just the human eye. It's actually pretty darn good at looking at differences. There's all the, and that's where it's kind of gets into the subjectivity of the issue and just looking at things. But we still use our human eyes for judging performance. We use the instruments and we get some good baselines, but at the end of the day, we always are also using our eyes.
Okay, another good question coming up. For consumer appliances, stainless steel, it's not just fingerprints that get on it, but also other food. Does the anti-fingerprinting coating still work for that? So I'm assuming you're talking about somebody like you've got kids and the kids have got ketchup on their fingers and they're putting them on your refrigerator door, etc. Obviously, it's bigger than just the fingerprint.
Absolutely, that's a great question. Fingerprints, because they have both water and oils in them, are actually pretty good. If we get a good AFP coating, usually it works pretty well against food as well, which is generally composed of water and may have some oils or fats, proteins. The same coatings that we've designed for AFP also are good for foods. We've done a number of different tests, especially on stainless steel against foods. So we've done tests against mustard, which can be pretty aggressive. So our treatments stand up to mustard, ketchup. They stand up to frying an egg. And most household cleaners. The only weakness we've had is against some of the polishes, which actually abrade the steel. So some of the really strong polishes have to be avoided. But other than that, against food and most household cleaners, we have really good durability and performance.
Okay. Another question on glass substrate. It's not only fingerprints, sometimes it's makeup as well. Does this work for that? So I'm assuming you're talking about like a mobile phone. If somebody's got some makeup on and it's getting onto the screen, that's obviously different than a fingerprint.
Yeah, that's a good question, and kind of similar to the food question I just previously answered. Our treatments do help against making surfaces easy to clean against makeup and other cosmetics. We test against hand cream and some lotions, and we've got good, very good, easy to clean properties. Sometimes the hiding power can be pretty challenging with those types of, if you glob something down with a big, glob of grease or sorry, like lotion, you will see that lotion, but the key is to kind of mitigate that, is to have a coating that allows that to just easily be wiped off, and we can give you that kind of performance.
Okay, great. Good. Well, I think that's all the questions. So thank you everybody for joining. We will be sending an email out to everybody who registered. They'll have a link to the presentation, a link to the recording. And obviously, please email us with any questions that you have. Again, thank you for listening into this working from home webinar series. We appreciate you taking the time. Be safe, be well, and we look forward to the end of this this time period. Okay, and with that, I will end the webinar. Thank you all.